For this week's Alteryx Weekly Challenge, we're using one of my favorite tools, which is the optimization tool. It's actually where my background is, so I thought that I'd use this as an opportunity to give a little bit of an intro to the optimization tool. So at the moment, the challenge that we're trying to solve, I've done a slightly different variation of what they asked for, but it still stands as a useful example. So we've got our variables up here, and in this case, I'm calling them xij. So that's the number of flower I in arrangement j, because we have j, which in this case is 10. We have 10 flower arrangements in total, and we've got 8 different flowers that can go into them, so that'll be flower I, and we just want to maximize the total number of flowers that we have in each arrangement. So that's our objective function here. The only constraints that we're subjected to are that all of our flowers, all the costs, whoops, there's no coefficient in here. Let me just put in a CI in there. Whoops, there you go. That's our cost coefficient. We just want to make sure that all of our costing of the flowers is less than our budget of 950. I think it's euros rather than dollars. Interesting. And then we've also got some constraints on the fact that we want between 4 and 8 of all of the flowers and 3 and 4 of all of the green things. So that's all that this notation is saying, and we just want our variables to be integers, which is what this notation here is saying as well. So that's kind of how I have to start by processing the problem, and I'll show you how that all translates into inputting it into the optimization tool. So let's take a look at our input data here, which is just our flowers, which is our variables, and the price, how much they cost. Now for our J's that we were talking about earlier, our arrangements, we're just doing a 1 to 10, and we're just going to append that on to our input data so that we have for each flower it's going to be repeated 10 times, basically. And then when we're going to join those two together to create our variables. So red rose 1 is basically the red rose would be the I and the 1 would be the J. So our ith flower and our jth arrangement, if that makes sense to you. So then we've got 80 variables there. We've got a flower for each arrangement, and we want to know how many of those flowers we're going to put in. So that's our variable that we've got here. Our coefficient for all of these is just 1 because that's what we're going to multiply our variable by. We're only going to count them once. So that's kind of, in this example, quite redundant. Our type is an I for integer because we want it to be a whole number, because we can't buy half a flower. That doesn't make any sense. And then we've got some upper bounds and some lower bounds. So the only kind of distinction that we have between the variables are these filagreens. They need to be between 3 and 4, whereas all the other flowers need to be between 4 and 8. And if we just get rid of some of these extra columns, then we've already done our objective function. And we just need to make sure that these are lowercase. I initially typed them in as uppercase, but these need to be lowercase so that the optimization tool recognizes them. You can also do a way to map the various fields onto the correct places, but it's just easier and quicker if you name it just the right thing and if you have a vague understanding of what those things mean. And then the only thing left to do for the objective function is just sort these in ascending order. It's just to make sure that everything goes into the optimization tool in the same order, and it's just almost like a fail-safe way of making sure the tool works for you. So now that we've got our objective function, so basically so far we have got this bit ticked off. We've created all of our variables, so we can tick that off, and we've built our objective function out. Awesome. So now we're looking at these constraints. I mean, actually, we've even dealt with these upper and lower bounds. So we can tick those off, and the fact that we've checked that they're all integers. So we've ticked that bit off as well. The only thing left is our constraint. And in this case, we've only got one constraint. So if we go back to Alteryx, then we come down here, and we only actually need our variable and our price now. And that is basically, we have one variable per row, and we've got the coefficient associated with it in the same row as well. So we've got a column for the variables, a column for the coefficients associated. And that's what I've forgotten right at the beginning, that's CI. So we've got that sort of side of the constraint sorted out, and we're just going to sort it again in the same way here. And then we bring in another, so that goes into our A input. And basically the reason it's called A and B, if I quickly explain that, usually like the general notation for a linear program would be such that, if I can find my mouse, where's it gone? There it is, sorry. It would be, you'd have AX is less than or equal to B. And that's why that's the notation of the optimization tool. So the A would be a matrix that has all your constraints in it, your X's are your variables, and your B are sort of like the right-hand side of that equation. And that would be a vector instead. So that's just a bit of background on why it's the A and the B inputs. So for the A input, that is just obviously everything about the variables, so those coefficients that we need. So we're just feeding that in to here, and then our right-hand side and our direction. So we're just telling Alteryx the constraint is the price, because that matches up to our coefficients there. And our direction is less than or equal to, and our right-hand side is 950. And that's as simple as it needs to be, basically. This is quite a simple problem. So our input mode is the specifying the model as matrices. You can do it by entering it manually or selecting it from a file, but obviously putting it in not just inputting it manually is always going to be more dynamic, obviously. And our problem type is a mixed integer program because we want our solution, our variables, to be whole numbers. We don't want to have like 1.5 roses because that doesn't make any sense. And it's not quadratic or linear because basically for the reasons I explained. The solver, this is a very efficient solver. Just take Alteryx's word for it. Do we want to maximize the objective? Yes, so we need to click this so that it changes over to the yes, because by default it will choose to minimize it, and we don't want to minimize the number of flowers, we want to maximize the number of flowers. And then we just need to make sure that we've said that our variables are in the rows, because that's the way we've chosen to structure it, because there are a lot of variables. There are 80 variables in this instance, so it doesn't really make sense to have 80 columns. And the ways to find out different ways of configuring this is to go into, I think it's in here, and then, no, it's in help, and then sample workflows, and then the predictive tools in the prescriptive analytics. This is really good for looking at the different ways that you can input things into the optimization tool. As for our problem, when we just run that through, then we get, this is the output. So we can see that our objective value is the same as in the output. It's 417. But then because I've chosen to look at the specific arrangements themselves as the different variables, then we've got slightly different numbers when we kind of sum these together. But that's not an issue. It's the same objective value, and therefore it's just one solution can have many different variations. You know, there's not always just a one solution to these things. So this is just another variation of getting there. So I hope that was a useful introduction to the optimization tool, and thanks for listening.